In this video, we'll be talking about the distance formula, midpoint, and the circle. So the distance formula is represented by d equals the square root of x2 minus x1 squared plus y2 minus y1 squared, where x1, y1 is the first point, P in this case, and x2, y2 is the second point, Q. The midpoint formula is still using the same 2 points, but instead the formula is m equals to x1 plus x2 over 2, comma y1 plus y2 over 2, because it's an actual coordinate as opposed to an actual value in the distance. Let's do an example. For the points P, -5, -6, and Q, 7, -1, find the distance and the coordinates of the midpoint of the line segment PQ. So, first thing we're going to do is let's label our P and Q. So you want to rewrite P and Q, and we want to label it as x1, y1, and x2, y2. Now, the distance of PQ, according to the formula, is square root of x2 minus x1 squared. So 7 minus -5 squared plus y2 minus y1 squared. -1 minus -6 squared. Okay, so negative negatives is positive, so 7 plus 5 is actually 12, and 12 squared is, alright, 12 squared for now, plus -1 plus 6 is 5, and that's under square root, and then we evaluate that, so it'll be 144 plus 25, and it's still under square root. Now 144 plus 25 is actually square root of 169, which we know the square root of, and that's just 13. So the distance between P and Q is 13. Now to find the midpoint of PQ, we use the formula x1 plus x2 over 2, that's the x coordinate, and y1 plus y2 over 2 is the y coordinate. So it would be -5 plus 7 over 2 and -6 plus -1 over 2. So that gives us -5 plus 7 is 2 divided by 2 is 1, and then -6 minus 1 is -7 over 2. So that would be our midpoint. So basically what it tells us is that if we plot this, -5, -6, that's our P, and then our Q is 7, -1, right here, we would have the distance between them would be 13, and then we have some midpoint around here. That's our M of 1, -7 over 2. Determine if 3 points -6, -4, 0, -2, and -10, 8 are the vertices of a right triangle. So to determine this, we need to find the sides of our right triangle first, and then plug them into the Pythagorean theorem to see if it's true or not. So in order to find the sides of a triangle, we need to find the distance between each set of points first. First thing we want to do is we want to label the points as A, B, and C respectively. And then let's find the distance between each one. So the distance of the first pair would be a and b would be, so x2 minus x1, so it'd be 0 minus negative 6 squared plus y2 minus y1, so negative 2 minus negative 4 squared square root. So positive 6 squared is 36, and then negative 2 plus 4 is positive 2 squared is a positive 4. So we add them, we get square root of 40. So I'm just going to leave it as square root of 40 for now. No need to rationalize, because it'll make sense in a little bit. The next distance will be between A and C. So point A, point C. So this gives us, so now our x2 is negative 10 minus x1, negative 6 squared, plus y2 is 8 minus negative 4 squared. And then sorry about that, it's square root the whole thing. So negative 10 plus 6 squared is negative 4 squared, which is 16. And then 8 plus 4 is 12 squared, which is 144. So we add them, we get square root of 160. And then finally, the last distance will be between points B and C. So x2 is negative 10 minus x1 is 0 plus 8 minus negative 2 under square root. So negative 10 squared is 100. 8 plus 2 squared, so 8 plus 2 is 10 squared is another 100. So that means that when we add them together, we get square root of 200. So these three values are the distance of each points, which also represents the sides of the triangle, of our right triangle. So we know that the Pythagorean theorem states we have a squared plus b squared is equal to c squared, where a and b are the two legs and c is the longer side, which is the hypotenuse. So if we look at our three distances here, the longest one, the highest value, would be the square root of 200. So we can automatically say that's our c side. That means that square root of 40 and square root of 160 are a and b. Doesn't matter which one we say. So say this is a, this is b. So applying that to the Pythagorean theorem, will it be true or not? In this case, so we would have, let's write it down here as square root of 40 squared plus square root of 160 squared. And we're checking, is that equal to square root of 200 squared? In this case it is, because if we square root square root of 40, we get 40. If we square root of 160, we get 160. And we know 40 plus 160 is 200, which is equal to that right-hand side of 200. That's true. So the question is, are the 3 points vertices of a right triangle? In this case, it would be yes. By applying the distance formula to the points. All right, so let's look at another example. Determine if 3 points, negative 4, 1, 1, 4, and negative 6, negative 1 are the vertices of a right triangle. So let's assign ABCs to each point. So we call the first one A, second one B, and third point C. And let's find, just like before, find the distance between each point. So let's first find the distance between point A and point B. So applying the distance formula, we're going to have x2 minus x1. So we're going to have 1 minus negative 4 squared plus y2 minus y1. So it's going to be 4 minus 1 squared. And that's all under square root. So let's simplify that. So we're going to have A negative 4 gets us a positive 4, so it'll be 1 plus 4 squared plus another, it'll be 4 minus 1 squared. If we simplify it further, 1 plus 4 is 5, 5 squared gives us 25, plus 4 minus 1 is 3, and 3 squared gives us 9. So if you were to add them together, 25 plus 9 gives us square root 34. And we could simplify that, but let's keep it under the root for now. Let's do the same thing for distance between points A and C. So between A and C, we're going to have x2 minus x1, so negative 6 minus negative 4 squared plus, and then our y2 minus y1, so this would be negative 1 minus 1. And that will be squared again, all under the square root. So let's simplify this. So negative 6 plus 4, that gives us, negative 6 plus 4 is negative 2 quantity squared, plus negative 1 minus 1 is another negative 2 squared. And if we were to square that, it would be 4 plus 4 gives you root 8. Now, let's kind of fit this last part down here between points B and C, distance between B and C. So we're going to have x2 minus x1, so negative 6 minus 1 squared plus negative 1 minus 4 squared, all under square root. It's kind of hard to write down here. So I'm going to write on the right. So negative 6 minus 1 squared is negative 7. Squared gives us 49. And a negative 1 minus 4 is negative 5. Squared gives us 25. And if we were to add them, 49 plus 25, so that would be 69 plus 5, 74. Now, let's assign these distances as A, B, and C. So let's call this A, B, and C. So if we apply the Pythagorean theorem, because we're talking about a right triangle here, A squared plus B squared equals C squared, will we get that? So if we say A squared plus B squared is C squared, that would be root 34 squared plus root 8 squared equals to root 74 squared. But if you notice, that'll give us just 34 plus 8, and that will not be equal to 74. So these 3 points will not be vertices of a right triangle, and we can see that by the graph here. If you notice, these points, when they're plotted, do not look like a right triangle. So our answer here would be no. It is not a right triangle. Now let's look at a little bit of a different example. Determine if the 3 points 0, 9, negative 3, negative 7, and 2, 19 are collinear. So by definition, what it means to be collinear is that these 3 points lie on the same line. So if we were to graph them, would we see them be on the same line? That's what we're trying to figure out. And also, the sum of the distance between 2 points should be equal to the distance between the 2 furthest points from each other. So the best way to figure this question out is, again, using the distance formula. So first things first is let's label each point as A, B, and C respectively. Let's call the first point A, second B, and third is C. So let's find the distance between point A and B. So applying the formula, we have x2 minus x1, so negative 3 minus 0, so we know it's going to be just negative 3 squared, plus y2 minus y1, so it's going to be negative 7 minus 9 squared. And that's all in the square root. So we know that Negative 3 squared gives us positive 9. Negative 7 minus 9 is actually negative 16. And if you were to square that, you get, using your calculator, you get 256. Okay, so then let's actually just add them together. So that gives us square root of 265. Now, because the numbers are kind of not nice, let's go and just actually take the square root of 265. So it gives us approximately 16.27 as a decimal. All right, so now let's find the distance between A and C. So this is formula, x2 minus x1, so 2 minus 0 is going to be 2 squared plus, and then we have 19 minus 9 for y2 minus y1 squared. So that will give us 4 plus 10, or squared, which gives us 100. And if you add them together, you get root 104. Now, let's take a square root of 104. Gives us about 10.20. So it's approximately 10.20. Let's look at the last distance. So between point B and point C. So x2 minus x1. So we're looking at 2 minus negative 3. So let's actually write it out. Squared plus. So now we have 19 minus negative 7. And that's still squared, all under square root. So 2 plus 3 is 5. 5 squared gives us 25. This one might give us a big number. So we have 19 plus 7, that's 26. And then 26 squared gives us 676. And if we add them together, take square root. So 676 plus 25 give us square root of 701, which approximately as a decimal would be 26.47. Okay, so let's label each decimal here as A, B, C respectively. Or let's call it capital A, capital B, and capital C. So if you notice, if we were to take A plus B, what will we get? C. And the reason why we picked the last one to be C, because 26.47 is the biggest of the three numbers. So it will be the biggest distance between the points. So if we had to plug it in, we would have 16.27 plus 10.20, which is 26.47. So that would be yes. And if you were to look at the graph, you'd see that they all lie in the same line, because we can see that, let's say 0, 9, that's A, so we can call this A here. That's negative 3, negative 7 is down here for B, and up here, all the way somewhere up here, would have to be 219, and that's our C. So they all lie in the same line, thus, yes, they are collinear. So now let's talk about the equation for a circle. So a circle is a closed curve in a plane whose points are at some fixed distance r, and from a given point hk, where hk is considered the center of the circle. So in the xy plane, the center radius form of a circle, which is a common form you'll see the circle equation in, is x minus h squared plus y minus k squared equals to r squared. So applying that knowledge, let's look at this example here. So we want to find the center and the radius and the equation of the circle given from this graph here. So from this graph here, you can actually just look at it and determine and see that the center of the circle here will be 0, 0, because right at the dead center of our graph. at the origin. Now, determine the radius. The radius, by definition, is the distance from the center to any edge of the circle. So if we count here from our center here, the red dot, we count how many spaces there are, it ends up right over here at 12. So that means that the distance from the center to, let's say, the right side of the circle, the distance would be 12. So we know that our center is 0, 0, and our radius is 12. So applying it into the center radius form of our circle, that would give us technically x minus h, which is 0 squared, plus y minus k, so minus 0 again, squared, equals to 12 squared. That's our r squared. So simplifying a little bit, x minus 0, it's just x, so it'll be x squared. Same thing for the y squared equals to 144. So this right here is the equation of our circle in center radius form. Another example. So find the center, radius, and this equation of the circle. We can see that the center of our circle this time is right here. And then we can say that's represented by the point, so our center is 1, -3. And then from that center, we count to the edge. So let's say this is from the center, we have 1, 2, 3, 4, 5, 6, 7 units. So the radius has to be 7. So writing this equation in center radius form, so keep in mind that this is our h component and this is our k component. So writing it as it would be x minus 1 squared plus. Now by default, it's always x minus h, y minus h, or y minus k. So it gives us y minus -3 squared equals to 7 squared. So cleaning it up, this stays as x minus 1 squared. Over here though, it will be a positive 3, y plus 3 squared, and then 7 squared gives us 49. That's our equation in center radius form. So you want to be careful. By default, it's always x minus h squared and y minus k squared. So if your point happens to have a negative, it actually flips the sign to make it a positive inside the center radius form equation. This example, we want to identify the center, the radius, and then graph the following equation. So our equation is x minus 3 quantity squared plus y plus 2 quantity squared equals to 9. So we notice that it's already written in center radius form, so we can automatically identify our center as 3 and -2. And the reason why it's -2 is because you remember the center radius form, the default are x minus h and y minus k. So you can think of this as y minus -2. That's why our h value is -2. And for our radius, so we know on the right side here is going to be our r squared. So if r squared is 9, then r itself would just be 3, because the square root of 9 gives us 3. And if we were to graph it, it would look something like this, where you graph your center first, 3, -2, and then you move any direction, 3 spaces, up, down, left, or right, and then you connect your dots and it creates your circle. Let's look at another one. Again, identify the center, radius, and graph the following equation. So we have x minus 3 quantity squared plus y squared equals to 1. So it does look like the center radius form. Let's remind it as x minus h squared plus y minus k squared equals r squared. So it looks a lot like it, especially the x minus h part, because that's our x minus 3 over here. But we notice that it doesn't look like the y minus k part. However, we can actually rewrite this equation to make it look like more like the center radius form as x minus 3 squared plus y minus 0 squared equals to 1. Because when you subtract or add 0, it's like you're not adding or subtracting anything. So you can actually rewrite this as y minus 0 squared. Now that we've written it this way, we can now see that our center is going to be 3 and 0. So our center point is going to be 3 comma 0, and our radius, again, r squared is 1. That tells us r has to be just 1. And if we were to graph it, we would again plot our center, 3 comma 0, and go up 1, down 1, left 1, right 1, and connect your dots. That gives you the graph of the circle. There are some instances where your circle equation isn't in the more obvious center radius form. Sometimes it might be in what's called the general form. So the general form states we have x squared plus y squared plus ax plus by plus c equals 0, where a, b, c are constants. So you might be asked to convert from the general form back into the center radius form. So let's talk about how we do that. So to convert it, we need to have to do a couple steps here. First, what we do is we need to group up all the terms involving x and do the same thing for those involving y. And then the next step is make sure the c, the independent term, is on the right side of the equation. And then when you go through the process of completing the square for the x and the y respectively. Then what you do is after you do that, you factor the left side of the equation and then simplify the right, and make sure you're in the center radius form, x minus h squared plus y minus k squared is equal to r squared. Then finally you want to interpret your results, because depending on what your r is, if r squared is greater than 0, then the equation describes a circle with a center radius r, a radius of r and center at hk. If r squared is equal to 0, then it's just a point at h comma k. And if r is less than 0, then the graph doesn't exist, because r is considered a distance, and you can't have a negative distance. It doesn't make sense. So let's look at an example. Transform the following equation to center radius form. So as a reminder, the center radius form is x minus h squared plus y minus k squared is equal to r squared. So that's the form we want to get into. Right now our equation is in general form. So the first thing we want to do is group up our x's and y's, and then bring that singular c term, the independent term, the negative 11, move it over to the right side. So we're going to have x squared minus 8x plus y squared plus 6y. And if we move negative 11 over to the right side, we get positive 11. Now we want to complete the square for both the x's and y's separately. So for the complete square, take the b value for the x, which is negative 8, divided by 2, and we square it. So negative 4, 8 divided by 2 is negative 4 squared is 16. Same thing for the y's, so 6 divided by 2 squared, and that gives us 9. So we take the 16 and 9, we add it on the left side next to the x and y respectively, but we also need to add to the right side to keep our equation balanced. So we're going to have x squared minus 8x plus 16 plus y squared plus 6y plus 9, and we go ahead and add 11 plus 16 plus 9. Okay, so now if you look at the x and the y, we can actually factor them because they're now become perfect squares. And if you remember, you can think of two ways. You can think of it as b over 2, or you can think of two numbers and multiply, you choose positive 16, add to get you negative 8. That would be negative 4, negative 4. So x minus 4 squared. And then plus, same for the y. It would have to be y plus 3 squared. And then on the right side, if we add everything together, that's 36. Now we look at what we have. It is in center radius form, but we want to look at our r squared. So if our r squared is 36, we know that 36 is greater than 0. That means that it would be a circle. So our equation, this is a circle, right? And that is, and the equation is in, this is our equation in sinus radius form. So last example here, we have a similar scenario. Determine if the equation is a circle or not. So it's written general form. So we need to group up our x's and y's and move that independent term 8 over to the right side. So we're going to have x squared minus 4x, y squared minus 4y. If we move 8 over, it becomes a negative 8 on the right side. Complete the square for both the x and the y. So our b value is negative 4 for both. We square them. Negative 4 divided by 2 is negative 2. Squared is 4. Same thing for the b value for the y. That's also 4. So we add 4's to both x and y, and also on the right side. So we have x squared minus 4x plus 4 plus y squared minus 4y plus 4, and that's equal to negative 8 plus 4 plus 4. So if we factor the x's and y's respectively, this should be x minus 2 squared plus y minus 2 squared. But what happens on the right here? Negative 8 plus 4 plus 4 is actually 0. So our equation is in center radius form. However, our radius in this case is actually 0. So because our radius is 0, this equation represents a point centered at, so the h and k in this case would be 2, 2, because h and k would be, and then we have x minus 2, y minus 2. So it would be a point at 2, 2. And the radius is 0, that means there is no distance, it's not moving anywhere. It's just a singular point.